thing I have to do is you got to tell me your thoughts on the test. My last class was like, they didn't like it. So I need to know your thoughts on the test. So type it in the chat, come off mute, just talk to me. Tell me what your thoughts on the test are. Terrifying. Yeah, they did. You died. Wow. I got one person to say it's okay. Thank you, Jamari. Imani said it was easy. You had stuff you didn't know. Did you study? Did you cover all the bases? Because of the thoughts from the other class it was the way that they asked the questions. It's not that they had. So do you agree with that? It was just the way they asked the questions. Okay. It's not that they asked on topics that you weren't aware of. They just asked it in a weird way.
Cause yeah, I think there was this one question where I spent like a good majority of the class time on, and it involved a chart, but like it never specified where it starts or ends, and then the way they ask the questions under, yeah, it was very weird
Okay.
worded.
Okay. Okay. Well, that's good to know. You feel, oh my goodness. Y'all were that nervous. Some of y'all were very nervous. Well, I'm glad they did that for you, Andre. You got your dinosaur moment in there. I'm glad you did that. Wow. Okay. And I don't know why like I said, I it's hard to prepare you for a test like that because I don't write it. It's top secret vaulted kind, and all we can do is tell you the topics that are on it and pray um, that you at least have some clue. This is why I kept saying vocabulary, 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 because if you know the vocabulary, then you can probably try to figure out what the question is asking. Because we weren't able to practice you on questions that they are actually going to ask. So that was difficult. Neve, do you have a question? Not okay, there's two Neve. That's the other class. Neve, you are logged into the wrong class. This is fourth period. Hope you hear me. And then you didn't just okay. All right. Well, as Taylor Swift would say, it's over and done. Shake it off. And we'll just wait to see what happens with the results. But at least you know what it looked like. All right. So what I want to do today is look at where am I? I'm going to look at environmental issues and human impact, and then I want to give you a chance to finish working on that Earth Day project. So they kind of overlap with each other. I do have a project for you to do later on that will kind of be like the end of year project. And it'll be have something to do with ecosystems, but it's not it. So I do want you to finish that Earth Day challenge, but I want you to look at this first. And as we go through this, there's a couple of videos that we're going to watch together. And then I'm going to, like I said, give you a chance to finish up that project. So if you would turn to Canvas to the environmental issues and human impact. And we'll look at that. Okay. All right, so when we look at it, two of the vocabulary words that you needed to be familiar with were renewable and non-renewable resources. So there are all the resources are things that we use on the planet, and renewable means that it can be replaced naturally. So they come from natural products like plants and animals, the soil, the water, the air, the wind. The sun's not going anywhere, and the earth is going to stay hot, so it's going to give you the geothermal energy. So these are things that can be replaced. We can grow more crops, we can raise more animals. The dirt isn't going anywhere. There's a lot of water. We just have to, and it says if it's carefully managed, means if we don't pollute it, we have enough water that we can use. The problem is we are polluting everything, and so things that we need become unusable. The other one is non-renewable resources, and those things cannot be recycled or replaced fast enough. So we have fossil fuels, and fossil fuels came from living things, but it takes millions of years for the dead things to be pressurized in order to make fuel. So even though things are dying every day, they're not being pressurized in such a way that we can use that. Nuclear power depends on uranium and nuclear metals. So like all the rest of these metals, if it's in limited supply on the earth, so they're going to run out. So we can't just say that this is what we're going to use all the time, because there is a limit to that too. So we have to try, so our focus is on using renewable resources like the solar energy and geothermal and wind. So we want to see windmills all over the place. We want to see solar panels set up, and we want to see hydro power is also good too. So these three right here are excellent because there's a lot of it. So we're not running in danger of running out of those. So this diagram you need to be familiar with. The things that affect our health, and this is where it ties into your project that you're working on, because you had to look at the human aspect of all of those topics. So the greenhouse effect. This time of year, we kind of appreciate, well, actually, we don't appreciate. In the wintertime, you appreciate the greenhouse effect on your car because you want the sun's rays go in through the windshield, get trapped inside the car, make the car all nice and warm and toasty. This time of year, not so much, because then you get in there and the car is too hot to sit inside, which is what we're experiencing with global warming, is that the rays are coming in, they're getting trapped, because our nice little blanket around the earth of carbon dioxide is preventing it from escaping like it should. And so our blanket is getting thicker and thicker, and our planet's getting warmer and warmer, and the heat is staying with us as opposed to escaping. So that is the greenhouse effect. Greenhouses like that because you set the glass up, the heat goes in, the plants get warm, and they grow. We don't like that so much because we don't like that kind of heat. So that's a problem for us. All right, so we're going to watch this little video here because it is short. And
why should adding carbon dioxide to the atmosphere be cause for alarm? It's a non-toxic gas, it helps plants grow, and unlike oxygen and nitrogen, the amount of CO2 in the atmosphere is quite small. But through the physics of the greenhouse effect, its consequences are significant. The greenhouse effect itself is a good thing. Without it, life on Earth would be extremely cold. About half of the radiant energy coming from the sun enters the Earth's atmosphere. This warms the Earth. The Earth in turn re-radiates energy as infrared radiation or heat. Much of that heat escapes back into outer space. Energy comes in and goes out, producing an average temperature equilibrium. Without the greenhouse effect, that average temperature would be 0 degrees Fahrenheit. Even the oceans would freeze. The reason this doesn't happen is because gases like methane, carbon dioxide, nitrous oxide, ozone, and water vapor, what we call greenhouse gases, absorb some of the infrared radiation in our atmosphere. These gases re-emit heat back to Earth's surface, and help the Earth's temperature heat up to an average of 59 degrees Fahrenheit.
It's as real as gravity, and it keeps the planet habitable. We'd have an average surface temperature on the Earth below the freezing point of water were it not for the greenhouse effect.
But since the beginning of the Industrial Revolution, humans have been adding carbon dioxide to the atmosphere by burning fossil fuels like coal, oil, and natural gas. When these fuels are burned, the carbon within them combines with oxygen in the air to form new carbon dioxide. Each time we burn coal for electricity or drive our cars, we're adding more CO2 into the atmosphere. And more carbon dioxide means our atmosphere is able to absorb more heat. Most scientists agree that the Earth's global temperature will continue to rise as long as we continue to burn fossil fuels.
So again, human impact. We have a lot to do with controlling what is going on and global warming. Okay, so global warming is the idea that temperature rise will cause a combination of different effects. Okay? And one of them is all the low-lying land areas like California and Florida. With the water rising, they'll disappear. Our coastline will disappear. We'll have beachfront property be a whole lot closer to you than it used to be if the water keeps rising the way it is because of global warming. All right, our next topic is pollution. Sorry. Another thing that we are desperately setting out of whack is the air quality, the ground around us, soil contamination, and water pollution. Two words that you need to be aware of are biodegradable waste products. Microorganisms, if things are natural and renewable, microorganisms can work on them and break them down, and they can return to the soil and they can be reused again. Things that are not biodegradable, like plastic, stay around forever because they don't break down. Okay, so that's where our pollution comes in. So these are all the different, so soil pollution affects the crops, the animals that we eat, it affects the plants that we grow, and then all of these things get in our body and create pesticides and pests and all kinds of other diseases and things that we don't want. And then with the air pollution comes acid rain. Now, this is a video that they don't talk very much. They just kind of illustrate. So we'll watch it real quick. All right, so the issue with, so these gases up here get into, when it rains, gases dissolve in water. And when those types of gases dissolve in water, they create acid. So we create sulfuric acid and nitric acid. And what goes up comes down. So it comes down in the lakes and streams, and it kills the fish because they don't like acid. The leaves, it destroys the leaves on the trees and the vegetation, so your crops can get spoiled from acid rain. Buildings used to be made from limestone, not so much anymore, but it erodes, it dissolves the limestone, so it erodes the building. Statues, some of the statues that you see that used to have a face don't have a face anymore. It's because of acid rain that has dissolved the thing that the statues were made up of. And then, so again, it's caused by all of the pollutants that come from cars and factories going in the air. So like I said, what goes up dissolves in the water and then comes down and then starts destroying everything on ground level. All right, biomagnification. Biomagnification means it accumulates, and as it accumulates, it gets bigger and bigger. So what starts off as a small effect, because it goes up the food chain, it becomes a big effect. All right, so we're going to watch this little bit. This one is not so short, but um, it's interesting.
Despite world record levels of pollution by mercury and PCB, the Arctic is still one of the world's least polluted areas when measuring pollution in plants and soil. Herbivorous animals, or those close to the bottom of the food chain, have very low levels of contamination. Animals at the top of the food chain, on the other hand, accumulate mercury and PCB to an alarming degree.
Her på Svalbard så det da isbjørn, polarrev og polarmåke som har de høyeste nivåene av for eksempel PCB. Når det gjelder organiske miljøgifter, så det slik at vi ser at det da ulike nivå i ulike arter av sjøfugl. De sjøfuglene som spiser mat som fra lavere trofisk nivå, de har veldig lave nivå av miljøgifter. De artene som spiser fisk, de får da et høyere nivå, mens de som utgjør toppen av næringskjeden, det vil si sånn som polarmåke og svartbakk, de har de høyeste nivåene. Veldig tynn, helt avmagret. Så den skal vi ta inn i laboratoriet, og så skal vi ta prøver av den inne.
The emaciated condition of this bird has special significance. The environmental toxin PCB accumulates in fat, so when the gull draws on its fat reserves, PCB is released into the blood. Climatic conditions, high pressure and low pressure, are what cause large air masses filled with pollutants from industries in Europe, Russia, Asia and North America to be pumped up to the Arctic. This is particularly true in the winter and spring. And transportation on the air is surprisingly fast. A discharge in Europe can reach the Arctic in a matter of days. And in the space of a few weeks, environmental toxins can be absorbed into the Arctic food chain. Contaminants conveyed via the sea are considerably slower. It is thought that there could be a delayed effect of up to several decades before some chemicals reach the Arctic. Studies of polar bears in East Greenland and Svalbard show a high level of contamination.
The polar bear have higher PCB levels than any other Arctic species, which is due to its location at the very top of the Arctic food chain. It eats the ring seal, mainly the blubber, due to the higher energy content, which is about 50% higher. But the ring seal stores more than energy in its blubber. It also stores the lipophilic substances like persistent organic pollutants and organic mercury as well. A polar bear of 200 kilo will ingest more than a ton of blubber within a year, which is a tremendous amount of PCBs.
Studies of polar bears indicate that high levels of PCB affect the hormonal system and lead to a weakened immune response, possibly to a degree that will affect the polar bear's survival capacity.
Okay, so basically what they're saying is what they eat accumulates in their body. So when they eat, it's the little bit is not affecting the fish, okay? But the polar bear is eating a lot of fish, so it accumulates a lot in the fat of the polar bear, and it becomes a problem for them. Okay, the same thing with us. We are, and most of you probably are not big fish eaters, but the fish, we're worried there's mercury in the water, and the fish are accumulating mercury. The fish are not dying from the mercury, it's staying in their tissue, but then we eat fish. So say if you were a fish eater and you ate that fish every day this week, all that mercury would be accumulating in your body at a higher level than it is in that fish. Okay, so that's biomagnification. All right, and pesticides. We want, because the planet is growing, we want to feed everybody, and we want to make sure we have a lot of crop in order to make sure that we can feed them. So we add pesticides to keep the bugs from killing off the crop, but the pesticides have problems too. So that is a problem. ozone depletion. We have layers to the atmosphere, and there is a layer in the layer called the ozone layer. And it's important, but if we mess it up, then we get messed up.
In this investigation, we look at a trend that climate scientists around the world are tracking: changes in the ozone layer. Between 20 and 50 kilometers above Earth's surface, the atmosphere contains a relatively high concentration of ozone gas. This is called the ozone layer. Ozone at that level is formed when the sun's ultraviolet rays strike molecules of oxygen, or O2. Some of the energy is absorbed and splits the molecules. The resulting single atoms of oxygen immediately bond with other O2 molecules to make O3 molecules, known as ozone. The naturally occurring ozone layer in the upper atmosphere is beneficial. It absorbs a good deal of harmful ultraviolet, or UV, radiation from the sun, preventing it from reaching Earth's surface. By shielding the biosphere from UV rays in this way, the ozone layer serves as a global sunscreen. This protective barrier is important because too much UV exposure can cause skin cancer, damage eyes, and decrease organisms' resistance to disease. For example, each year more than 800,000 Americans develop skin cancer, and more than 9,000 die from it. Satellite data in the early 1970s gave scientists the first clues that the ozone layer was in trouble. The first sign was extremely low ozone readings from sensors on a satellite. The very low values for ozone measurements taken over much of Antarctica in winter was described as a hole in the ozone layer. Since then, holes in the ozone layer have appeared and grown over Antarctica and the Arctic and parts of South America. In 1974, scientists theorized that human-made chlorofluorocarbons, or CFCs, were damaging the ozone layer. CFCs were once widely used as propellants in aerosol cans, as refrigerants in refrigerators and air conditioners, and in the production of plastic foam cups and fast food containers. It is the chlorine in CFCs that damages the ozone layer. Today, most uses of the old harmful CFCs are banned, and the level of chlorine from CFCs in the atmosphere has begun to fall. Current assessments indicate that the ban on CFCs is working, and the ozone holes should shrink and disappear within 50 years. In this instance, years of gathering scientific data has uncovered the ozone depletion problem. It has also helped scientists understand its human-made source and provided a solution. Scientists will continue to track levels of ozone in the upper atmosphere to be sure the ozone holes continue to shrink, returning the ozone layer to its natural balance.
Okay, so you notice deodorants are more roll-ons and stick. They're not a whole lot of spray deodorants anymore, because that was one of the biggest problems. So many people were using them because they had the chlorofluorocarbons, or that gas that's inside that pushes all that other stuff out, all the good stuff that you want to use. It has to be pushed out under pressure. So the chlorofluorocarbons were allowing them to do that. So they don't have spray cans like that anymore. Certain paints have spray cans, but they have something else inside. So they've gotten rid of, this original source of pollution. Air conditioners. You have to be a licensed air conditioner person in order to work on air conditioners, because they don't want to accidentally release the freon that goes in there that helps keep things cold. All right, extinction. So there are 3 levels of danger as far as living things are concerned. The first level is they are threatened. So when the things that we're doing cause the population to decline, the organisms are put on the threatened list, and their special protection is set up for them. And if it continues to go down, then they become endangered, and then it becomes illegal to do certain things. The laws are set up so that you can't do this and you can't do that. If that doesn't work, then they become extinct. So the objective is to identify organisms as being threatened, do what is necessary to increase their population before they become endangered. Okay, because if we allow them to stay endangered, then extinction is the next step. All righty. These guys, you should be familiar with these. Kudzu grows all over Georgia. And it's called an invasive species because it was not native to Georgia. They brought it in. They were trying to feed the crops and do some other things, and then it just took over and grew in places where it didn't belong. The problem with invasive species is they overtake the natural species, and the natural species dies out, and the invasive species takes over. Okay. So, all right. This is the last one. This one's a little long, and I may not show it as long as it is, but there is a funny looking fish that is also an invasive species.
There is an invasion underway on the Atlantic coast. An alien species has moved in, and our marine habitats are under attack.
There are thousands, probably millions of them out there now.
These non-native predators will devour almost anything that gets in their way.
They'll eat anything up to half their size. They'll eat non-stop until they're about to pop.
And their numbers are growing fast.
Each individual female can produce over 100,000 little juveniles a year.
Their presence here threatens the very existence of our coral reef systems and the native wildlife that inhabits them.
This is a major marine invasion. It makes me think of a forest fire. It starts small, and then before you know it, it grows out of hand. It's really hard to imagine being able to put out this fire, and it's spreading.
Who are these invaders? Where did they come from? And what can be done to stop them before it's too late?
They just don't belong in the Atlantic Ocean. And they're here to stay.
The invasion began here in Florida in the 1990s. But who are these fishy aliens? And where did they come from? Mark Albans from Oregon State University has been monitoring the invaders since 2007.
The Indo-Pacific red lionfish is from the Indo-Pacific. Well, we're here in the Atlantic, and it's a fish that is not supposed to be here.
So if they're not supposed to be here, why are they here? And how did they get here?
They're one of the most popular aquarium fishes. People buy them because they're beautiful, beautiful fish. They've got striking appearance and coloration. People put those in their aquarium and they grow really fast, and they tend to eat all the fish in the aquarium. So people want to release these fish because they want to do what they think is the right thing. So they go down to their closest dock and release the fish. Unfortunately, that's happened enough times that lionfish have been able to establish reproductive populations in the Atlantic. And since the early 1990s, they've been spreading like wildfire. Now they can be found from as far north as Cape Hatteras, North Carolina, all the way down to the northern coast of Colombia in South America.
Okay, so you might wonder, why do we care? Here's a fish from the Pacific Ocean that's doing really well in the Atlantic. So what? The Perry Institute for Marine Science in the Bahamas has been a field station for coral reef and fish studies since the 1960s. Mark and his team, and their colleague Tim Pusak, are here in their 4th summer of fieldwork studying the impact of the lionfish invasion.
A lot of times people talk about coral reefs as being equivalent to the tropical rainforests of the sea.
The coral reef is a system that's delicately balanced. Everything's connected.
There's a wide range of types of fish, types of coral, types of algae that live on these reefs. That diversity, that's what makes life what it is on this planet.
Corals provide structure for other animals to come in, other fish to congregate around, and they help to build the foundation to a whole ecosystem, a whole environment. So you remove any one of those parts, and then the system might start to break down.
The guys are running a number of experiments. They catch lionfish and measure and tag them, and then release them so they can watch their behavior and see how they affect other reef fish. They survey the natural reefs, count the number of lionfish living there, and record their findings. They then carry out experiments on controlled reefs, some of which have been created from natural reef structures, and others which have been made completely from scratch by Tim and his team. After 4 years of work, it's becoming really clear just how much Pacific lionfish are affecting life on Atlantic reefs. And some of the stuff they're finding out is pretty scary.
Each individual female can produce over 100,000 little juveniles a year. And as those spread, they can disperse far and wide over the ocean. So they can become widely dispersed very fast.
The main problem with the lionfish is that they're an invasive species. They're not supposed to be here. And they're changing the system. And they're changing the system by eating a lot of small fish and by competing with bigger fish for food.
This doesn't sound good. Our coral reefs are already suffering because of overfishing, pollution, and climate change. But what I want to know is, why aren't there any bigger fish eating lionfish?
Lionfish are well protected by an array of venomous spines, and that makes them really tough to eat. Also, native predator fish don't recognize them as potential food, so they don't recognize them, they don't try and eat them.
And with no bigger fish to keep them in check, they are free to eat anything and everything they can. What's more, lionfish are supreme hunters and can strike in the blink of an eye. Watch this. Wow, gone in a flash. Let's see that again. The students at the Coral Shores High School in the Florida Keys have been investigating just how remarkable the lionfish's hunting abilities are.
Well, the last couple of years, the lionfish haven't really been known very well down here. Once in a while, someone would be like, oh, I saw a lionfish. And over the past 6 or 7 months, they've just blown up. They're everywhere now. I mean, you can't go really diving or snorkeling without seeing lionfish.
They'll eat anything up to half their size. They'll eat nonstop until they're about to pop. The ones we've actually had in the tank, I've seen a couple of them look like they're about to pop. They've eaten so much.
You will be Devin? Okay, thank you.
The students and their teacher, David Makepeace, wanted to understand how lionfish can strike so fast.
We watch 2 fish, we blink, and there's 1 fish, and we don't see quite what happened in between. And so trying to figure out what happened was fascinating.
To get a better look at the lionfish's amazing hunting ability, we sent in our camera crew, armed with the latest high-speed technology. These cameras can record at frame rates of up to 2,000 frames per second, which produces incredible slow-motion shots. So first, a quick demonstration. And Charles has volunteered to get wet. Now let's see that back in super slow motion. Now let's see if, using this technology, we can get a more detailed look at a captive lionfish as it strikes. For this, we'll be needing another volunteer. Oh yes, he'll do nicely.
We have a lionfish and a prey fish. We have the Phantom camera set up at 2,000 frames per second, and it's shooting always, and then after we see the action that we'd like to film happen, then we hit the record switch and it gets it. So we have a big slow motion shot.
And we don't have to wait long for the greedy lionfish to make his move.
We watched them flare their gills, and in flaring their gills, they were actually able to create a void which drew water into their mouths and drew the prey in with it.
Wow.
You can actually see the fish.
We're able to see through the gill opening and watch the fish actually going through the mouth and into the gullet. And that was fascinating. Felt a little sad for the prey fish, but that's life in the food chain.
And it's the lionfish that are now at the top of the food chain on many of our Florida, Bahamas, and Caribbean reefs. But one organization is committed to changing that balance by becoming the lionfish's #1 enemy. REEF, the Reef Environmental Education Foundation, has begun organizing events called Lionfish Derbies.
Lionfish Derby is a great way to involve the community in going out and removing a lot of lionfish. It's an event, it's a single-day event, so we have people out using nets and using spears, trying to remove as many lionfish as they can, but also biggest lionfish and smallest fish. And we have cash prizes for the winners in 3 categories. It's a great opportunity to reach out to the community, educate, increase awareness, and it's a great way to remove a lot of lionfish in a single event.
We got one! And so? It's better than none! And we had fun! Maybe with any luck it'll be the biggest.
There's 73 lionfish.
Yeah, how many lionfish did you guys get?
15!
Every single lionfish is measured and scored,
76.
then handed to Pam Schofield and her team from the U.S. Geological Survey.
When lionfish are small, which you can see, many of these are very small, they tend to eat invertebrates. So we're concerned they could be eating things like pink shrimp, they could be eating small stone crabs, possibly even lobsters. We just don't know. We are removing the stomachs, and then we're going to take those back to the lab, and in a laboratory, very controlled situation, we'll be opening them up and carefully identifying and measuring what the lionfish are actually eating.
Nothing goes to waste here. The lionfish are now prepared for the hungry hunter's supper.
We're going to put this into ceviche so everybody can have a taste. For those people that know what hogfish tastes like, it's very similar to that. It's a very light, delicate meat. You can season it many different ways. It's not strong or fishy flavored. And yeah, absolutely, it's great.
There it is. It's a mild white meat. It's really delicious.
That's it, huh? No, that's the fish we didn't see today.
Yeah, it's hot. It's good.
It's delicious, it really is.
It's a really mild fish. Tastes really good. Salty, lime. I like it. It's good.
Over 100 people from as far afield as Oregon took part in today's derby, and between them managed to collect over 500 lionfish from the waters around the Florida Keys. Of course, this is just the tip of the iceberg. The problems caused by the lionfish invasion won't be solved overnight. But it's a step in the right direction, and a reminder to us all not to make this mistake again.
If you have an exotic pet and you don't want it anymore, make sure that you don't release it into nature. You take it to a pet store, take it to animal control in your local community, and turn it over to them to deal with as is appropriate.
People always think that there's a fix. They always think, well, can't they think of something? Well, they is us. And in the case of problems like invasive exotics, especially something like lionfish, there's not a do-over button. We don't get a chance to rewind. It's done. Now it's a matter of facing the consequences of what was done and maybe learning from it so that we don't do it again.
We got the third biggest and the second smallest.
We got this for the smallest lionfish, which 50 millimeters is like this.
The largest lionfish.
Largest.
Fantastic. Congratulations. Yeah. Hey, he caught it.
Second place for the most lionfish was 75.
75. And who caught the most lionfish?
Gee. I'll take responsibility for that.
All right, so that's just an example of bringing things to where they don't belong. Florida has a big problem with things like that because people have a tendency to have a lot of exotic things. I was in Fort Lauderdale and you got peacocks walking around the street because people release their peacocks out. Iguanas are all over the place. They just walk around the street all over the place because people take iguana as a pet, then they don't want it anymore, and they send it out in the woods, and then they overpopulate. So that is not the way to get rid of a pet that you don't want anymore. All right, so that's it for that. I want you to now work on your most of you have not turned this in, so we need to make sure we get that turned in. Excuse me, your Earth Day project. All right, so again, if you're looking for it and you hadn't started it yet, it's in the same module with all of the testing stuff. And so you don't have to do anything but answer the questions. There's no pictures that you need to do. You just need to answer the questions. Okay, you need to do that and send it back. All right, so this is due this week. So we're going to try, because we don't have a lot of time. We got 3 weeks left of school. We want to make sure that we stay on track. We do the assignments that are due. Work when you're in class, do that assignment and get it done. I think one person might have completed this. So I'm going to stop talking, stop doing new stuff, and then you work on this assignment. Okay. So again, it can be found in the folder with all the other extra things we did for the milestone test. Let me do attendance. Got one person absent. Maybe. right, did anybody do a Nearpod that I need to check on? I think I got all of those logged in. No, I didn't. Actually, no. All right, so we only had half the folks finish up the food webs, food chains. So folks, before, as much as I want that Earth Day project done, I really want you to finish those Nearpods if you haven't done one. Let me check on the food chain, food web, because most half of those are missing. Last time I checked. All right, anybody have a question on what they should be doing? Like I said, I only have 3 people. Let me check it in. Let's see, 3 people who have done their Earth Day challenge. Everybody else has that to do. So y'all got a few things to do to get caught up. Earth Day challenge, food webs, food chains. Did you try sending it to me in Outlook? The in system one? Let me see what that should be. Okay, let me try it. Outlook inbox. I don't know if you didn't answer it in the negative text. Yeah, everybody needs to. Yeah, do the Nearpods first. Please do the Nearpods first. Please, please, please do the Nearpods first. I'm gonna go in and check on scores for that in a minute. What is? I'm trying to figure out. Okay, I'm trying to figure out how to do that. Okay, let me. So what is it? I'm trying to figure out what that is. It does, you can't. I'll see what I can do, Andre. Malaysia, when you go, let me show you how, because I'm not sure what my actual email address is. Everybody just goes into Outlook that's already on, and that's how they send stuff to me. Yours isn't set up like mine, where you have Outlook on the side here and you just click on it. See, when I try to do that, let me try to send you one and then you can send me something back. Excuse me. Let's see. Okay. Sure. Okay. All right, Malaysia. I'm sending you an email, so you just send me one back. So look in your Outlook and you can just attach it to that. Just respond to the one I sent you. All right, Audrey, let me see what I can do for you. I have too many things open here. Well, maybe it takes a minute, but I didn't get it. But I'll keep checking. You got one from me? Okay, well, then it'll probably take a minute. Because it's not there. Although all of these are old. Why are they so old? Last email I got was Saturday. That's weird. All right, well, I'll look for it. Okay, Andre, remind me to give you these tomorrow. I'm gonna try to download something for you. In the meantime, folks, it is time to go. So stop where you are, and I will see you tomorrow. Have a great rest of your day.